Alright, so this next problem I was going to look at here is a problem for the probability unit, obviously, and it deals with mutually exclusive events. For mutually exclusive events, it's basically getting at if you have two things happening, event A and event B, is there a chance that there are things that, possibilities that would both be in A and B? And what I mean is, like the common example we're going to use here is cards. And we're going to look at if you were to draw two cards, so event A is card 1, event 2 is card B, is there a chance that A and B could be the same thing? Is there such thing as a 7 and a club? And the answer is yes. So for this first example here I've got, where we need to find the probability of the event, there's a card that is a 7 of clubs. So if I say event A is drawing a 7, and I say event B is drawing a club, you can have both of those happen at the same time if that one card comes up as a 7 of clubs. So what that means is, and this is the first thing you want to ask yourself when you're finding the probability of events, is it mutually exclusive or not? So this one is mutually exclusive, or sorry, is non-mutually exclusive. And what that means, I said this in class, if you want to call it this way, you can call this mutually inclusive. You really have to get the wording down on this. It basically means that they're not separate. In the Venn diagram, they overlap. There is that common outcome, which in this case is the 7 of clubs. It changes the way we approach the problem. You need to pick this formula, which I know it looks fancy, but it's really quite simple. This is the formula off your formula sheet. It basically says the probability of two events, one or the other, if it's non-mutually exclusive, is this. And that's the fancy version. The everyday version of this is basically you add the probability of the two events together, but you subtract the overlap. Because in this case, if you just went probability of a 7 plus probability of a club, you've counted the 7 of clubs in both groups. So what you have to do is you have to cut out the overlap, basically. So here we want the probability of a 7 or a club. The probability, that's going to be the probability of a 7 plus the probability of a club, minus the probability of the 7 of clubs. Okay? So first, the probability of getting a 7. Well, if it's a standard 52 card deck, and I want to find the probability of getting this, well, it's going to be 4 out of 52. There's 4 7s in a 52 card deck. And I'm going to add that. Or always hints at adding. The probability of getting a club, well, is one of the 4 suits. So it's 13 out of the 52 cards. We've got to subtract out that one card that's the 7 of clubs. 4 plus 13, 17, minus 1, 16. So this one's 16 out of 52. Okay? Now over here, a heart or not a red card. Again, we've got to ask ourselves, is this mutually exclusive or not? Are there any overlapping, like for event A and event B, is there any common outcomes? Again, with a Venn diagram, which I can draw under here. If this is event A and this is event B, do they overlap like that? Or do they look more like this, where they don't touch? There's no common elements. Well, the first one, a heart, is a red card. Not a red card is kind of a way of saying black card. So in this case, there are no common elements. There's no way you can get a heart that is also a black card. And again, this not can make this confusing. So here it is, this one is mutually exclusive. So here, I'm going to use a different formula for my formula sheet, which is basically this one we used over here, but we're not taking out the overlap because there is none. So here, we've got the probability of a heart, and I'm going to put red with a line over top. Remember, that means complement. So one of the ways to write complement, the other one's the tick. And then that's going to be the probability of a heart plus the probability of getting a red, not a red. So this one, probability of getting a heart. Well, there's 13 hearts in a 52 card deck. So I have a 13 out of 52 chance of getting a heart. Or I can get not a red card, which is basically any black. And I have 26 out of 52 as a chance for that. No overlap to subtract out, so you're just going to add numerators. 13 plus 26 is 39. So my probability is 39 out of 52 here. As a closing note here for this, when it comes to mutually exclusive and independent, You really need to know exactly what those things are, solidly. It's very, very important that you know what a mutually exclusive event is, what independent-dependent events are, and then after that, then the math follows. If you can't do this first step and identify, for a lot of the problems, it's over right there.